Now let's look at an example where we can use either a trig substitution or an algebraic substitution. So suppose we're trying to integrate x cubed times the square root of the quantity x squared plus 36. Well, one way we could do this is using a trig substitution. We could let x equal 6 times tangent of theta. But I'm going to show you another way that we can do this same problem using an algebraic substitution. So what we're going to do here is we're going to let u equal x squared plus 36. Then du will equal 2x dx. So what happens when we make the substitution? Well, under the square root we'll have u, and then what do we have remaining? Well, we have an x cubed dx. We know that x dx can be replaced with 1/2 du. So we're going to think about this x cubed dx as an x squared times x dx. The x dx we replace with 1/2 du, leaving us with an x squared. Well, x squared we can express in terms of u by here subtracting 36 from both sides, and we'll have that u minus 36 equals x squared. Of u minus 36 times the square root of u du. And now this is something we can integrate if we simply distribute the square root of u. So now we'll have 1/2 times the integral of u to the 3/2 power minus 36 times u to the 1/2 power. And this is something now that we can easily integrate. So 1/2 times, well, this becomes u to the 5/2 power, and we multiply by 2/5, minus 36, and this becomes u to the 3/2 power, and we multiply by 2/3, plus our constant of integration. And now we can clean up the constants a little bit and do a substitution in terms of the original variable. So we'll have a 1/2 times 2/5, and instead of u, we're writing x squared plus 36 to the 5/2 power, minus 24 times x squared plus 36 to the 3/2 power, plus our constant of integration as our final answer.